My core area of research is currently in social media, social networks, and I'm really looking into how incivility is handled in these networks. One of the big questions in political science right now, and one of the biggest concerns, deals with polarization. So we know elite polarization exists. We see it with the inability of lawmakers to agree on subjects, to get things done. We even saw it recently with the Gorsuch nomination, where the Senate, which was usually the deliberative branch, threw the filibuster out the window. So this was largely due to elite polarization. So there's a bigger question as to what that means for the public. So does mass polarization exist? And there's a big debate over that. What I'm trying to do is look at a little slice of that and look at affective rhetoric and affective polarization, which basically is polarization amongst people based on feelings or, in some cases, hatred for the other party. Maybe not ideological, but still concerning nonetheless. So I track hashtags, I track keywords or names, and ampersands, which is user accounts. So currently I'm tracking at POTUS, at Real Donald Trump, mentions of Donald Trump, and then other topics like fake news. That's an interesting political football. The Gorsuch nomination, I've been tracking that. So right now I'm focusing on Twitter because it's the easiest to access, and a lot of people are doing it too. I'm really interested in getting into Facebook, and even image recognition or analysis on Instagram, Pinterest, things like that, where eventually, as I progress through my career, land that all elusive goal of a tenure track position, get in touch with computer scientists who are able to write that kind of code and look at these images, because images are an important part of communication too. It's more difficult to interpret than tweets, but it's still an important part of human communication, and that forms these social networks. What this type of research does, this broad network analysis, is you're looking at a specific type of person who's communicating, but you're looking at it at a very broad sort of, I know it's always said 30,000 feet. You're looking at it from above where you can identify these patterns. So what that helps you do next is say, okay, something's happening here. It looks different than when it happens under different conditions. So why is it happening under this condition and not happening under this new condition? And you can get in and look and do a fine level analysis of the types of people who are communicating in this little sub-community, the types of language they're using, their ideological preferences. You can glean that out of the hashtags they tend to use, the URLs that they link to, the types of people they mention. So you can build a better picture of what is this person's ideology, and how are they behaving. So it kind of gives you a map. It gives you a roadmap. I use Gephi, which utilizes some very complicated algorithms that I don't pretend to know the mechanics of, but I understand what they're doing. And what they do basically is you have your node, which is your individual, your participant in a network, and you have edges. The edges are a connection between two nodes or two people. So that could be a retweet, a tweet mentioning someone, a reply. Any sort of connection between those two nodes will create an edge. When one node or one person sends a message to somebody else, and then that gets retweeted to, say, 10 people, suddenly what happens is the original node is connected to a node that gets larger. So the node size is the number of in and out messages. And then I assign an eigenvector value to the name size. So the larger the name is, that's a measure of their influence, and that's based on the number of nodes the nodes that they are connected to are connected with. So over a number of different iterations, you start seeing this map where of all these different connections and the strength and influence of these connections. One of the neat things is, too, there are calculations for the graph as a whole. So we can get a calculation of the diameter of the graph, which is the maximum length from one end to the other between all these connections, and then the average path length. So that tells us how efficient the graph is. And that's one of the things I look for signs of homophily, which would be a potential sign for polarization, which means ideological silos.
Really how far apart those
right,
are.
Exactly. So I think this research would be helpful to policymakers from a way to judge the effectiveness of different types of initiatives. So the ability of a policymaker or a business person to focus in and cut through the BS, the noise, the static, and isolate a specific variable they want to look at. I mean, you can do that with this analysis. If you have a solid objective, a solid question, you can do that. And one of the really neat, it's neat, but it's powerful. It's a powerful tool that this provides is, when we're talking one-on-one, I mean, I know what I'm telling you. You know what I'm telling you, but I don't know what you're going to say when you go talk to somebody else, and what those people will tell other people. So if I give you, it's kind of like the old telephone game we played in grade school. Like I whisper it in your ear, and it goes from, I'm baking a pie for dinner to you're all going to die tomorrow. It's the telephone game, but it applies. So what this analysis lets us do is we can look beyond this one-to-one communication, and I can see what my message is doing, once it leaves you, to the wider community. So it lets us pull back from, say, a policy-making war room or a marketing think tank room where they're coming up with these great ideas and they let them out into the wild. Well, this allows them to pull back and see how that propagates throughout the network of the people who are going to be impacted by it or the people who are going to buy the product. And once you see where these hot spots are or where you're getting different reactions, you can then focus in to that area and get your hard data and it's like a macro micro analysis. You balance the two. So it's a really powerful tool from both perspectives. It allows you to create your treasure map and then go to where the treasure is located and dig it up. So, I was thinking a lot about my influences when you asked me about that, and my core influences are my parents, because largely they set the tone for me. They set the example. My mother taught public school, grade school for 25 years, always interested in psychology. She'd always talk about, trying to understand people's motivations for behavior, and that was there that kind of brought me up to kind of think about, why do people act the way they do? Political science, in a large way, is we're looking at human behavior. I mean, humans are political animals, we're social animals, and it seems like that kind of comes together. My father, electrical engineer, multiple patents, worked for McDonnell Douglas, Boeing, so he was always approaching problem definition and problem solution. So, those influences early on of, tackling these problems and trying to explain why they're important, why they matter to people. That formed my core influence. My background is not maybe traditional for a political scientist. I have a music background, classical music, English literature, philosophy, an MBA thrown in there. But I think that kind of forms the way I approach looking at problems from maybe a broader, like a broad background. To try to draw upon different experiences, different schools of thought, to try to look at problems from a different angle, I suppose. As far as my academic career, definitely have to give huge props to Dave Robertson at University of Missouri, St. Louis. when I started the program, he knew my background, and he was always, really encouraging me to define the question. What is the question? Focus on the question. And he had the mantra, kind of like in real estate, instead of location, 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 he would tell me focus, focus, focus. So, he's been my biggest influence as far as a political scientist goes, for sure. When I started my PhD program in 2011, I knew that I wanted to focus on the internet. I wanted to know about internet and politics, how the internet and social media is changing, how people deal with politics, how we interact with each other. But as it progressed, I started to look more at the relationship. I was more interested in the history of the telegraph and how that informs us about the history of the internet. So I was really fascinated that a lot of our internet rules today are based on laws from the 1930s, 1934 Telecommunications Act, the 1996 Act. But it's fascinating because they don't fit. The telegraph, we often hear that the internet is the equivalent of the modern day telegraph, or that the telegraph was the Victorian internet. And there are a lot of really good comparisons, but they're not one-to-one comparisons. So I spent a year, that was going to be my dissertation, looking at comparing, doing a historical analysis from an American political development approach of the internet versus the telegraph. So that's still in the works. I was told by Dr. Robertson, Dave Robertson, do that after your dissertation. You have your whole life to work on that. But as I started swinging back to social media, it's like, how can I measure this more closely? And I just started reading more about network analysis, and I had a project. I wanted to follow the primaries, and I thought, okay, this is a perfect chance to test this and to learn about network analysis. So that's really where it all began. I'm not so necessarily worried about proving something or disproving something or telling so-and-so you were wrong about that theory. And I'm not worried about somebody telling me I was wrong. Hopefully I can present a new way of looking at things and find something interesting, and hopefully somebody corrects me and makes it better and finds a new way of doing it, because in the end that's really what's important, I think.